These 4 in a row or Connect 4 games are really, really good because even though it says addition, it should actually say additive, meaning you're having students work both with addition and subtraction, as in the multiplication versions are multiplication and division. They are seeing factors and multiples here, all sorts. Now, if you're working so focused, you could be really structured and build up very explicit things, but I rather let's keep it as game-like as possible for now, and then later unpack deeper. So the playing of it, I like when I run them off the photocopier, I like folding it and then laminating it or putting it in one of the sleeves. So in the instructions it says moving paper clips. That would work, using paper clips only when you have it folded, but still I prefer using the dry erase board markers. So whatever you do to have people start, whether it's rock, paper, scissors or what, it doesn't really matter to me. It's let's really talk about the modeling and the reasoning. So in a game, I would have whatever materials out that would be expected to be used. Certainly in the beginning, modeling work is really, really important so that we can build independence, which is the key for any two students to be able to go away with the good equipment to be able to do it with accuracy. So I prefer to have people start on these spots, and let's pretend those are paper clips. So whoever gets to start first gets to move one of these. Now, when I'm trying to build this up, I actually just say, you need to win by connecting 4 in a row, by using these to add to make those. And then the next level step would be to focus students on only being able to move one. So, in the beginning, the X team would say, choose, oh, they want to get 12. So whatever they have to do to make 12, it could be a 10 and a 2. Well, I don't have these, so I have to change things around a bit. The nearest to 10 plus 2 would be take 1 off of there and return 1 to here. 5 plus 4, 9, or 1 less than 10, and 3. 9 plus 3 is 12. Nine plus 1, 2, 3, 12. Or I start at 9, I get 1, 2, 3 more, I finish at 12. To eventually have, I started at 9, I get 3 more, and I finish at 12. I know it's not easy to see on this far away. I just don't have my 0 to 30 number line here. Anyway, player 1 goes. Player 2 decides they want to get 10. And you can do this because it's our early starter version. We're going to get 5 plus 5 because that's the one they remember. 5 plus 5 makes 10. 5 plus 1, 2, 3, 4, 5 gets us to 10. That's a jump of 5. Now, that's showing that double. Okay? If we were working with you only get to move one, I have to leave one on 5 and move the other anywhere I so choose. If I'm trying to think, I want one of these things in particular, for example, if I wanted 16, I'd be now thinking of how can I make 16 when I've already started at 5. I would be encouraging, how do I make 16 if all I have is a 5? 5, 10, and one more is 11. Or, how do I make 16 if all I have is a 5? I need 5 to make 10, 5 more is 15, and 16. That's 5, 10, 11. Or, they are counting from 5 to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How do I make 16 by holding just one finger on it? Because I know it's 10 and 6. Anyways, can't do it with these numbers, and I'm not allowed to invent new ones, so I have to either choose a different number or get more creative. That more creative would only be realizing that I need to choose a smaller number than 16 because the largest addend is 9. So let's try to find 13. I only need to get to 13, and I have a 5 to start. That's 5, 6, 7, 8. I'll need 8. 5 plus 8 makes 13. And we can show it. 5, 1, 2, 3, 4, 5, 6, 7, 8. That's a jump of 8. I always get them to draw this jump of, even though they counted all the way up, because now they're showing what we would want to be seeing, that if I started at 5 and added 8, get to 13. If I started at 5 and added 8, gets me to 13. We're not part-holing, we were just counting and then deciding and realizing, oh hey, yes, that's what I did. Okay, and carry on until somebody wins. So, circle person's turn could be, I need to move one of these. If I want 17, I'm clearly going to move the 5. I have 8. 17 with 8 used up would be 7 and 1 more. Yes, I showed a different way on purpose. That relieves 9, meaning I started at 17, I knew I had to use 8, and I was left with 9. I need a 9. And on you go. The winner is 4 in a row. Okay, now, a small reckon rack or abacus is good, and number line is good. But have you ever used a picture of a reckon rack, or Slavonic abacus in this case, to show that same addition that you were doing here? So, use this plenty to support students in getting away from counting tallies. So, if they were trying to find out what 3 plus 9 is, and I want them to be really familiar with this, they could be finding 9 plus 1, 2, 3, and now realizing we have 10, 11, 12. Right? Or, due to pardon the interruption, 9, they can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 1, 2, 3. I encourage the drawing of the shape and staying tidy. Okay, they can also draw. I'll use the wider marker for this, it's way more powerful. Draw your 9. Okay, I know that's 9, 1 less than 10, excellent. And an 03, 1 to 3. Now this is what is helping towards the tidying up of the tens, making tidy tens to calculate. Let's take 1 off that and shove it in there, because now it's a 10 and 2, that's easy. Meaning 9 plus 3 is equivalent to 10 plus 2. We realize this by taking 1 from the 3 and putting it on the 9. Okay, another way for writing is I have my 9 add 3, and if I took 1 from the 3 and put it on the 9, and I like showing how many I'm moving and where it's starting and going to, it is now a 10 there and a 2. This, compared to this, is much nicer, even though it's the exact same size. They're equivalent. Not the same,